Hello everyone, welcome to the Health Science channel GH. In this video, we are going to learn one of the most important topics in statistics and also in research method, which is hypothesis and hypothesis testing. We would also look at chi-square test statistic. Now, this topic is very important, especially for students studying statistics, students studying research methods, and also social sciences students. Now, by the end of this video, you would understand what hypothesis actually means. You would also understand the types of hypothesis and how hypothesis testing actually works in statistics. Now, let's begin. Now, let's look at what hypothesis actually means. What is the meaning of hypothesis? When we say hypothesis, what does it mean? Now, a hypothesis is simply a clear and a testable statement. Okay, it could be an assumption that is made about a population, okay, or about the relationship between variables. That is what we mean by hypothesis. So a hypothesis is a clear and a testable statement. It's like a statement that is not certain, okay, a statement that is more like a prediction, a testable statement. Is that okay? Good. Or an assumption made about a population, or an assumption made about the relationship between variables. Okay, good. So we can give you two variables, let's say gender and academic performance. Then you make a testable statement. You can make a statement like, okay, there is a relationship between gender and academic performance. That is a hypothesis. That may not be the fact, okay? But then when we collect information or we collect further details, we can confirm whether that statement is actually true or false. Okay, so such a statement is a hypothesis. It's a testable statement. It's a statement that we can test. Okay, so it is a statement we can make before actually collecting or analyzing data. And a hypothesis can either be true, it can be supported by the analysis, or it can be rejected using statistical methods. Okay, so for example, we can make a statement like there is no relationship between smoking and lung disease. There is no relationship between smoking and lung disease. Okay, so now these statements that I just made is a hypothesis. Okay, so if I make a statement like, okay, there is no relationship between smoking and lung disease, it's a hypothesis. Why? Because it can be that there is a relationship between smoking and lung disease. So hypothesis is more like a prediction. So let me give a blunt example. Like two schools are going to have a quiz. Okay, they are going in for a quiz. Then I make a statement like, okay, school A will win the quiz. The quiz have not yet been conducted. Then I make a statement like team A will win the quiz. Okay, someone also make a statement like no team will win the quiz. Okay, so this is a hypothesis, but at the end of the exercise, we will know which of the statements we are going to accept or which of the statements we are going to reject. That is more like a hypothesis. So a hypothesis is a clear and a testable statement or an assumption made about a population or about the relationship between variables. Now, in statistics, okay, in statistics, we have two types of hypothesis in statistics. There are two types of hypothesis in statistics. Now, we have the null hypothesis, and then the second type of hypothesis, we call it the alternative hypothesis. So we have two types of hypothesis in statistics. We have the null hypothesis and we have the alternative hypothesis. Okay, null hypothesis, or you can call it H naught. Okay, so H with subscript 0, H naught is also accepted. So you can call it, then we have the null hypothesis and the alternative hypothesis. Alternative hypothesis, you can also call it the H1 or HA. So we have two types of hypothesis in statistics, the null hypothesis and then the alternative hypothesis. Now, what is a null hypothesis? When we say null hypothesis, a null hypothesis is like a hypothesis that basically states that there is no relationship between variables, or there is no effect or no difference between variables. But usually we use the word relationship. So when we say a null hypothesis, so I give you two variables like gender and academic performance. If I tell you to state null hypothesis, you are just going to say that there is no relationship between gender and academic performance. It's simple as that. Okay, good. Now, so null hypothesis would always go like there is no relationship between variables. For example, I give you another variable like exercise and blood pressure, and I tell you to state null hypothesis. Null hypothesis will go like there is no relationship between exercise and blood pressure. That is the null hypothesis. So for null hypothesis would always establish that there is no relationship between variables. Is that okay? That is a null hypothesis. Okay, good. Then we have the alternative hypothesis. Now, alternative hypothesis, on the other hand, will state that there is a relationship between variables, or there is an effect, or there is a difference. But usually we use the word relationship. So for alternative hypothesis, when we give you two variables, alternative hypothesis will establish that there is a relationship between the two variables. Okay, so there is a relationship between the two variables. That is what we call alternative hypothesis. So there are two types of hypothesis in statistics. There are two types of hypothesis: the null hypothesis and then the alternative hypothesis. Null hypothesis would always establish that there is no effect, or there is no difference between the variables, or there is no relationship between two variables, or there is no relationship between the variables. So if I give you two variables like let's say exercise and blood pressure, and I tell you to write the null hypothesis, the null hypothesis, or H naught, is equal to, so the null hypothesis, or H naught, you are just going to write there is no relationship between exercise and blood pressure. If I give you another variable like gender and academic performance, I tell you to state null hypothesis, you are just going to write there is no relationship between gender and academic performance. Simple as that. Now, alternative hypothesis. For alternative hypothesis, it always states, or it always affirms that there is a relationship between variables. There is a relationship between variables, or there is a difference between variables, or there is an effect between variables. But usually we use the word relationship. Okay, so when we give you two variables like exercise and blood pressure, and I say state the alternative hypothesis, you are just going to write there is no relationship between exercise and blood pressure. Simple as that. So at the end of the day, you are going to test whether the null hypothesis, okay, is true, or the null hypothesis is false. You are also going to test at the end of a statistical test whether the alternative hypothesis is true or the alternative hypothesis is false. Now, there is one thing that you need to know in statistics. In statistics, okay, you can't say that you have rejected the null hypothesis. Okay, you can't say that you've rejected the null hypothesis. Usually we use the word we fail to what? We fail to reject the null hypothesis. Again, you can't also say that you have accepted the null hypothesis. Okay, you can't say that you've accepted the null hypothesis. Okay, the reason is because, you see, in a statistical test, if you do not have enough evidence, okay, what you can do is that you can make a statement that you fail, okay, you fail to reject the null hypothesis, but you can't completely say that you've accepted the null hypothesis. We fail to reject the null hypothesis. Is that okay? Great. I'll give you more details when we come to that. Now, why do we test hypothesis? Why do we have to test hypothesis? Okay, but before we even talk about the reason why we have to test hypothesis, let's talk about what hypothesis testing actually means. What is the meaning of hypothesis testing? Okay, now, hypothesis testing is a statistical procedure. Okay, when we say hypothesis testing, it's actually a statistical procedure. Okay, a hypothesis testing is a statistical procedure that we use to decide, okay, whether to accept or to reject a hypothesis based on a sample data. So when we say hypothesis testing, it's basically a statistical procedure used to decide whether to accept or to reject a hypothesis based on a sample data. Okay, now hypothesis testing basically compares what we have observed in a data with what we expect to see if the null hypothesis is true. That is hypothesis testing. It compares what we observed in a data with what we expect to see if indeed the null hypothesis is true. So if indeed, let's say the null hypothesis is the hypothesis that states that there is no relationship between variables. If actually the null hypothesis was actually true, what are we going to observe in the data? That is what hypothesis testing is actually all about. It tests whether what we observed in the data, okay, it compares what we observed with the data with what we expect to see if indeed the null hypothesis was true. Okay, so that we'll be able to gather evidence to confirm whether we have to actually, we have to actually reject the null hypothesis, or we have to fail to what? We have to fail to reject the null hypothesis. Is that okay? I mentioned that under no circumstance in statistical tests should you mention that we accept the null hypothesis. Instead of saying we accept the null hypothesis, we rather say we fail to reject the null hypothesis. The reason is because the fact that the statistical test did not give you enough evidence, okay, to actually accept the alternative hypothesis does not mean that you can say that you accept the null hypothesis. We don't say we accept null hypothesis. What you say is that we fail to reject the null hypothesis. Is that okay? And that is more like you've accepted it. Okay, but in statistics, we don't want you to mention that. I'll give you more details on that as we move on. Okay, so hypothesis testing is a statistical method that we use to make decisions or draw conclusions about the population based on the sample data. So it involves stating two opposing statements. The two opposing statements are the null hypothesis and then the alternative hypothesis, which is the H naught. Sorry, the null hypothesis, the H naught, and then the alternative hypothesis, the H1 or the HA. Okay, so it involves stating two opposing statements, the null hypothesis and alternative hypothesis, and using data to determine whether there is enough evidence to reject the null hypothesis. Now, in simple terms, hypothesis testing helps to decide whether an observed result is due to chance or represents a real effect or relationship. That is basically it about hypothesis testing. Now, what is the importance of hypothesis testing? Now, hypothesis testing is important because, one, it supports decision making. Okay, it supports decision making. Now, two, it helps to determine statistical significance. Three, it helps to validate researchers' claims. Okay, again, it reduces errors in conclusions. And hypothesis testing is widely applicable across several fields. In social sciences, in business, okay, in health sciences. It's widely applicable in several fields. It forms the foundation for inferential statistics. So now this is the reason why we do hypothesis testing. Now let's move on to chi-square testing. Chi-square testing in hypothesis testing. Chi-square testing. Okay. Now before we look at chi-square testing, what is chi-square test? Now remember that chi-square test is a form of hypothesis testing. Chi-square test. Okay. Sometimes they call it chi-square test statistic. It's the same thing. It's a form of hypothesis testing. Okay. So in statistics, once a hypothesis has been formulated, we use an appropriate statistical test to determine whether the hypothesis is supported by data. Okay, so in statistics, once a hypothesis has been formulated, we use an appropriate statistical test to determine whether the hypothesis is supported by data. Now, when hypothesis involves categorical or qualitative data, such as, let's say, gender, preference, class level, response type, the chi-square test is commonly used. Now, what this means is that we use chi-square test, okay, when we want to actually test the relationship between two categorical variables or two qualitative variables. So chi-square test is basically used when we want to actually understand the relationship that exists between two categorical variables or two qualitative variables. An example is gender. Someone will say, what is a categorical variable or what is a qualitative variable? First of all, a variable is any event that differ among individuals. An example can be sex. Sex can differ between two people. Someone can be a male, another person can be what? A female. So that makes it a variable. It vary from the word vary, variation. Okay. Another example of a variable can be your disease status. Your disease status. It can be someone have a disease or not. Someone may have a certain disease and another person too may not have the disease. So there can be a variation that makes it a variable. Smoking status. You can have someone who smoke and you can have someone who do not smoke. So you see, there can be variations in it that makes it qualitative. Okay. Now, but what makes a variable actually qualitative is any variable that naturally you can't measure it or naturally do not come, or you can't assign numbers to it naturally in terms of measurement, is a variable. An example can be sex or gender. Male, we can have male sex, female sex. Male does not represent 1 in statistics. Female does not represent 2 in terms of numbers. Do you get it? And so that makes it qualitative. Now, we use chi-square test to check the relationship between two qualitative variables. So, for example, we want to know the relationship between gender and academic performance. You see, gender is a qualitative variable. Academic performance is also a qualitative variable. You can have someone who is good academically and someone who is bad academically. Now, being good academically does not represent 1. And being bad academically does not naturally does not come with a certain number. You can't measure being good academically naturally with a certain number. You can't represent it with a certain number. So it makes it qualitative or categorical. Now, when we want to check the relationship between two categorical or qualitative variables, the best test to do is chi-square test statistic or chi-square testing. So chi-square testing is used when we want to check the relationship between two categorical variables. So for example, gender, preference, class level, response type. Chi-square testing is commonly used. So we use chi-square test when we want to understand the relationship between two categorical variables. Okay, so like I said, when do we use chi-square test? The chi-square test is used when data are categorical or qualitative in nature. So for example, male or female. You know, male or female gender is a categorical variable or qualitative. Yes or no. Responses like yes or no is a categorical variable. Yes does not represent 1. No does not represent 2 naturally. Okay, so it's a qualitative variable. Anytime you want to check the relationship between two categorical or qualitative variables, the best test to do is the chi-square test. Now, we can also do chi-square test when the data are presented in the form of frequencies or counts, not percentages. Okay, so if data are presented in the form of frequencies, that is one of the ways you can consider to do a chi-square test. Okay, also when you want to test association or relationship between two categorical variables, that is what I was explaining. Okay, again, the sample size should reasonably be large before you'll be able to do a chi-square test, the sample size should reasonably be large, and the expected frequencies are generally 5 or more in each category. Now, lastly, the observations are independent of each other. Now, what is the importance of chi-square test? Chi-square test, it tests the relationship between categorical variables. It does not require normal distribution. It's a simple and widely used form of hypothesis testing. Okay, so chi-square test is a form of hypothesis testing. Simply put, that is what I want you to understand. Now, the next thing I want you to understand is that we use chi-square test as a form of hypothesis testing when we want to test the relationship between two categorical variables or two qualitative variables. Now, let me repeat it again. We do chi-square test as a form of hypothesis testing when we want to understand the relationship between two categorical variables or two qualitative variables. Now, let's go and let's now begin to look at some examples of chi-square test. Let's do some examples, okay, of chi-square test. Now, let's start with question 1. Now, question 1 reads, a health worker wants to know whether there is a relationship between smoking status and the presence of lung disease among adults in a community. The data collected are shown below. So a health worker wants to know whether there is a relationship between smoking status and the presence of lung disease among adults in a community. The data collected are shown below. Okay, so we have the data here. We have smokers with lung disease 40, smokers with no lung disease 20, non-smokers with lung disease 20, non-smokers with no lung disease 40. Now, for the smokers, the total number of smokers is 40 plus 20, that is 60. Now, the total number of non-smokers, we have 20 plus 40, that is 60. Okay, now the number of people with lung disease is 40 plus 20, that is 60. The number of people with no lung disease is also 20 plus 40, that is 60. Okay, this type of table in statistics, we call it a 2x2 table. Now, the question goes ahead to say that test at 5% level of significance whether smoking status is related to lung disease. Okay, so let's go over the question again. A health worker wants to know whether there is a relationship between smoking status and the presence of lung disease among adults in a community. The data collected are shown below. Okay, so we have smokers with lung disease. So we have smoking status. So here is smoking status. So this column represents smoking status. So we have smokers and we have non-smokers. That is the smoking status. And here represent the disease, lung disease. So we have those with lung disease and those with no lung disease. Now, these are the totals and these are the rows. So these are the rows. But basically, this type of table, we call it a 2x2 table. So 2x2 table, here we have two rows. We have two rows, row 1 and row 2. We have two columns, column 1 and then column 2. So these are, we call these columns, and we call this is also column 1, this is column 2. You don't count this as part of the columns. Here, this is row 1, this is row 2. We don't count this as part of the rows. We don't count this as part of the rows. That is why we call this type of table in statistics a 2x2 table. Okay, so 2 rows and 2 columns. Now, the question goes ahead to say that test at 5% level of significance whether smoking status is related to lung disease. Is that okay? 5% level of significance means 95% confidence level. Okay, and anytime you have 5% level of significance, alpha level is 0.05. 5% is the same as 5 divided by 100, and that is 0.05. Now, let's go on to the solution. Let's go on to the solution or the analysis. Now, the first step in hypothesis testing is you have to state the hypothesis. The first thing to do during hypothesis testing is you state your hypothesis. That's the first thing to do during hypothesis testing. You state your hypothesis. Now, remember, we have 2 types of hypothesis and you have to state all the 2. The first step in hypothesis testing is you state your hypothesis. How many hypotheses do we have? We have 2 types of hypothesis. The null hypothesis and then the alternative hypothesis. So the first step in hypothesis testing is you state your hypothesis. How many hypotheses do you state? You state two types of hypothesis: the null hypothesis and then the alternative hypothesis. How do you state the hypothesis? You have to go read the question and check the variables you have. All the time, you'll be given two variables. Remember, we are doing chi-square testing and we use it to check the relationship between two qualitative variables. So you have to check the question for the variables. So the relationship. So see, a health worker wants to check whether there is a relationship between smoking status and the presence of lung disease. So the variables are smoking status and lung disease. So you now come and state your null hypothesis. In writing the null hypothesis, you are just going to state that there is no relationship between the variables. So look at how we write it. There is no relationship between smoking status and lung disease. There is no relationship between smoking status and lung disease. So it's very simple. The first step is you state your hypothesis. The first hypothesis is the null hypothesis or H0. You can just write the H0 is accepted. Then you write there is no relationship between smoking status and lung disease. Now, the alternative hypothesis, HE or H1, you write there is a relationship between smoking status and lung disease. Simple as that. There is a relationship between smoking status and lung disease. There is a relationship between smoking status and lung disease. Okay, so the first step in chi-square testing is you state your hypothesis, your two hypotheses, the null hypothesis and then the alternative hypothesis. How do you state the hypothesis? By checking the kind of variables you have in the question. With this example, the variables are smoking status and lung disease. So you just state the null hypothesis. There is no relationship between smoking status and lung disease. Then the alternative hypothesis, there is a relationship between smoking status and lung disease. Now, the second step in hypothesis testing is choose the level of significance. Choose the level of significance. So the second step in hypothesis testing is choose the level of significance. Choose the level of significance. Now, how do you get the level of significance? All the time, you'll be given the level of significance in the question. Now, the question says that test at 5% significance level. So it means the level of significance is 5%. That is 5 over 100. And that is equal to 0.05. 5 divided by 100 is equal to 0.05. And that is also called the alpha level. So that means once the level of significance is 5%, all it means is that the alpha level is 0.05. Once the level of significance is 5%, all it means is that the alpha level is 0.05. Is that okay? Now you can get, it's not all the time that the level of significance will be 5%. They can change it. They can give you a confidence level of, let's say, 98%. That means the level of significance will be 2%, which is 2 over 100. Is that okay? But most of the time in chi-square testing, the level of significance will be 5%. Once the level of significance is 5%, automatically the alpha level is 0.05. So the second step is you choose the level of significance. The second step is you choose the level of significance. Now the third step, you calculate the expected frequencies. You calculate the expected frequencies. Now, there's a formula for doing that. The formula for calculating expected frequency is equal to, into bracket, row total, close the bracket, multiplied by the column total, all over the grand total. Now, the formula for calculating the expected frequency is equal to, into bracket, row total, close the bracket, multiplied by the column total, all over the grand total. Now, before you calculate the expected frequency, you have to go back to the table. Now, remember, this table in chi-square test, that would be given you all the time in statistics, in the question, in the chi-square question. We call it the observed frequency table. This table that you are seeing in the question, we call it the observed frequency table. Now, this is the table that you would use to calculate the expected frequencies. Someone will ask, why are we calculating the expected frequency? The reason why we are calculating the expected frequency is that we want to know how the frequencies will look like if indeed there was actually no relationship between the variables, how the frequencies will look like. Okay, so these frequencies are the actual observed frequencies from the data. Now, the reason why we are going to calculate the expected frequency is that we want to see how will these observed frequencies look like if indeed there was actually no relationship between the variables. How would the frequencies, how would these frequencies that you are seeing look like? Okay, good. So before you calculate this expected frequencies, this is the formula, but you use this table. Okay, so now you come here. Now, like I was explaining earlier, this table, this is how we interpret the table. So you see, we have smokers who have lung disease, they are 40. We have smokers who do not have lung disease, they are 20. The total number of smokers is 40 plus 20, that is 60. And that is what gives us the row total. This is what we call the row total for the smokers. Now, here we have non-smokers with lung disease. They are also 20. We have non-smokers with no lung disease. They are 40. At the end of the day, the row total, the total number of non-smokers is 60. Okay. Now, if you want to calculate the expected, so we are going to calculate the expected frequency for this 40. So these are the frequencies: 40, 20, 20, and 40. They are the frequencies. These are the totals. They are not part of the frequencies, these ones. So the frequencies are 40, 20, 20, and 40. This 40 represents smokers with lung disease. They are 40. This 20 represents smokers with no lung disease. They are 20. This 20 also represents non-smokers with lung disease. They are 20. This 40 also represents non-smokers with no lung disease. Now, the formula says that if you want to know the expected frequency for this 40, okay, is the row total. What is the row? So you stand on this 40. What is the row total? Is 60. Then what is the column total? Is 60. The formula says that if you want to know the expected frequency for this, is this row total. Row total is 60 multiplied by this column total, which is 60. Then you divide by the grand total. This is 120. The grand total is 120. And that is what has been done over here. Okay, so if you come to the expected frequency, calculating the expected frequency, you have to draw another table. We call that table the expected frequency table. Remember, this table given to you in the question, we call it the observed frequency table. That is the table from the data itself. Okay, so if you want to know the expected frequency for this 40, you stand on this 40. What is the row total? 60. What is the column total? 60. The formula says that the formula is expected frequency for this 40 is the row total for this 40 multiplied by the column total for this 40 divided by the grand total. So what is the row total for this 40? Is 60. So you trace to the row total, 60. Then you trace to the column total, 60. So 60 multiplied by 60 divided by 120. And that is what has been done over here. So 60 multiplied by 60 divided by 120. That will give you 30. Now we will come back to the observed frequency table again. You stand on this 20. We are going to calculate the expected frequency for this 20. How do you calculate it? It's 20. So look at the row total for the 20, so 60. Look at the column total for the 20, so 60. The formula says multiply this 60 by this 60. So row total divided by column total. Row total multiplied by column total divided by the grand total, 120. And that is what has been done over here. So 60 multiplied by 60 divided by 120. That will give us 30. So let's come back to the table again. Okay, so we want to calculate the expected frequency for this. What is the formula? Row total multiplied by column total divided by the grand total. Now, this is the 20. This is the observed frequency. What is the row total? 60. Trace it to the row total, 60. Trace it to the column total, 60. 60 multiplied by 60 divided by the grand total, 120. All the time here, this is what we call the grand total. So the row total, 60 multiplied by 60 divided by 120. And that is what has been done over here. It's also 30. Now let's come to the expected frequency for the 20. For this 20. The same way, the expected frequency for this 20. Trace to the row total is 60. Trace to the column total, the same 60. The formula says multiply this 60 by 60 and divide by 120. That is what has been done over here. So 60 multiplied by 60 divided by 120. That is 30. You come down to the last one. we are going to calculate the expected frequency for this 40. What is the row total? 60. What is the column total? 60. So 60 multiplied by 60 divided by 120. And that is what has been done over here. 60 multiplied by 60 divided by 120. That is 30. Okay, good. So the third step is you calculate the expected frequency. What is the formula? Expected frequency is equal to row total multiplied by the column total divided by the grand total. The row total multiplied by the column total divided by the grand total. So that means at the step 3, you have to draw another table. We call that table expected frequency table. But then you use the observed frequency that is given you in the question. Okay, so you are going to calculate the expected frequency for this 40, expected frequency for this 20, expected frequency for this 20, and expected frequency for this 40. Now, how do you get the expected frequency for this 40? Is the row total, which is 60, multiplied by the column total. This is the column total, 60. So 60 multiplied by 60 divided by 120. When you come here to the same thing, how do you calculate the expected frequency for this 20? Is the row total 60 multiplied by the column total is also 60. Then you divide by 120. Okay, and that is what has been computed over here. Okay, so the expected frequency for 40 is 60 multiplied by 60 divided by 120. That is what has been done over here. So the 60 multiplied by 60 divided by 120, that is 30. Now, usually in most data, what you are going to get is the observed frequencies would be, the expected frequencies will be the same in most situations, not all the time. Okay, in most situations. But when we move on, I will explain for you to get a certain trick why usually these observed frequencies are the same. Is that okay? Great. So to calculate the expected frequency is the row total. So for this 40, is the row total is 60, the column total is 60. So 60 multiplied by 60 divided by the grand total, 120. If you want to get for this 20, the row total is 60, the column total is also 60. 60 multiplied by 60 divided by the grand total, 120. If you want to get for this 40, is 60 multiplied by 60 divided by the grand total, and that is what has been done for all. So you have to draw another table in the step 3. Now let's move on to the step 4. Step 4 is what we call compute the chi-square statistic. Compute the chi-square statistic, or compute the chi-square statistic. Over there too, we have another formula, and over there too, you draw another table. I will show you how we draw that table. Okay, so in that table, you are going to write. Now, look, from this table that has been given to you in the question, we actually have 4 categories. I'll explain how we get the 4 categories. From this table, we have 4 categories. Now, in the step 4, you are going to draw another table, but in a different format, using the 4 categories. Let me show you the 4 categories. Now, see. From this table, we actually have 4 categories. See, we have smokers with lung disease. They are 40. That is category 1. We have smokers with no lung disease. They are 20. That is category 2. We have non-smokers with lung disease. They are also 20. We have non-smokers with no lung disease. They are 40. Let me go over it again. From this table that is always going to be given in the question, we have 4 categories. We have smokers with lung disease, 40. We have smokers with no lung disease, 20. We have non-smokers with lung disease, 20. We have non-smokers with no lung disease, 40. So that tells you we have 4 categories. Now, in the step 4, come and draw the table in a different way. We want to see you writing all the 4 categories. So you see, we have category 1, smokers with lung disease. So you see, and from this table, okay, so you are going to draw a table that combines the observed frequency and the expected frequency. So you see, this table, we have 4 categories. Smokers with lung disease, 40. And this table is the observed frequency table. So smokers with lung disease, 40. Smokers with no lung disease, 20. Non-smokers with lung disease, 20. Non-smokers with no lung disease, 40. If you come to the expected frequency table, we have smokers with lung disease, 30. Smokers with no lung disease, 30. Non-smokers with lung disease, 30. Non-smokers with no lung disease, 30. So in the step 4, come and draw the table again, but this time we want to have a table where we have both the observed frequency and the expected frequency in that same table. So you use this format all the time. So you see we have the category, we have the observed frequency, the expected frequency. So you see we have smokers with lung disease, the observed frequency 40. Smokers with no lung disease, the observed frequency 20. Non-smokers with lung disease, the observed frequency 20. Non-smokers with no lung disease, the observed frequency 40. Is here. See, we have smokers with lung disease 40. That is what we have over here. Smokers with lung disease 40. That's for the observed frequency. Okay. And then the smokers with lung disease 30 for the expected frequency, and that is what we have over here. Smokers with lung disease, the expected frequency 30. Then we have smokers with no lung disease 20 for the observed frequency. Here is it. Smokers with no lung disease 20. So you see smokers with no lung disease 20 for the observed frequency. If you come over here, smokers with no lung disease 30. If you come over here, smokers with no lung disease, expected frequency 30. You do that for all the 4 categories. So you see, non-smokers with lung disease 20 for the observed. Non-smokers with lung disease 30 for the expected. That is what we have over here. Non-smokers with lung disease 20 for the observed. Non-smokers with lung disease 30 for the expected. Here is it. So non-smokers with lung disease 30. Okay, for the expected. Then the last one, non-smokers with no lung disease, okay, or observe is 40. So here is it. Non-smokers with no lung disease 40. That is what we've written over here. Non-smokers with no lung disease 40. And for the expected, non-smokers with no lung disease 30. And if you come over here, non-smokers with no lung disease expected 30. Okay, so in the step 4, you are going to first of all draw another table. On that table, we want to see all the 4 categories. Now, remember that this table is actually showing 4 categories, provided you understand the table. So, smokers with lung disease, first category. Smokers with no lung disease, second category. Non-smokers with lung disease, third category. Non-smokers with no lung disease, fourth category. So, the table is actually showing 4 different categories. Okay. Great. So in the step 4, you come and draw another table. Now, the step 4, how you are doing is you compute the chi-square statistic. You compute the chi-square statistics. Now, before you do this, you have to draw this table first. Now, you see we have a formula for computing the chi-square statistic. Now, chi-square, this S-square means we call it calculated chi-square. So calculated chi-square or computed chi-square is equal to summation of, into bracket, observed frequency minus expected, close the brackets, raise the power 2, all over expected. So calculated chi-square is equal to summation of, into brackets, O minus E, close the brackets, all squared, all over expected. This O represents observed frequency, E represents expected frequency, and then this E also represents expected frequency. So calculated chi-square is equal to summation of, into bracket, observed minus expected, close the bracket, all squared, all over expected. Calculated chi-square is equal to summation of, into bracket, observed minus expected, close the bracket, all squared, all over expected. Calculated chi-square is equal to summation of, into bracket, observed minus expected, close the bracket, all squared, all over expected. So now this formula, you are going to interpolate these frequencies into this formula for all the categories. Okay, so that's what I said. You are going to interpolate these frequencies into these formulas for all the categories. Okay, so let's start with the first category. Smokers with lung disease, the observed is 40, expected is 30. Here is it. So this is the observed frequency table. Smokers with lung disease, observed is 40. Okay, and then the expected is 30. Yeah, that is what we have over here. Smokers with lung disease, observed is 40, expected is 30. Okay, you interpolate that into the formula for the first category. Okay, so the formula says that observed minus expected, close the bracket, all squared, all over expected. Smokers with lung disease, observed is 40, expected is 30. Put it into the formula. Observed is 40, so 40 minus expected is 30. 40 minus 30, close the bracket, all squared, all over expected is 30. Here is the expected, 30. When you do the solution, you get 100 over 30. That will give us 3.33. Now, smokers with no lung disease, The observed is 20, expected is 30. Interpolate that into the formula. So observed minus expected, close the bracket, all squared, all over expected. Observed is 20. 20 minus expected is 30. 20 minus 30, close the bracket, all squared, all over 30. That will give us 100 over 30. That will also give us 3.33. Now, non-smokers with lung disease, observed is 20, expected is 30. Now, let's look at it. Now, interpolate that into the formula. So, observed minus expected, close the bracket, all squared, all over 30. Observed is 20, expected is 30. So, 20 minus 30, close the bracket, all squared, all over what? 30. That will also give us 3.33. Then you come to the last category, non-smokers. Non-smokers with no lung disease, observed is 40, expected is 30. Interpolate that into the formula. Formula says observed minus expected, close the bracket, all squared, all over expected. So observed is 40. 40 minus expected is 30. 40 minus 30, close the bracket, all squared, all over expected is 30. That will give us 3.33. Now, so the formula says summation. So that means we are going to add all the calculated chi-square for all the categories. So you are going to add 3.3 plus 3.3 plus 3.3 plus 3.3. So the calculated chi-square is equal to 3.3 plus 3.3 plus 3.3 plus 3.3. That will give us 13.32. Okay, 13.32. Because see, the formula says summation of, okay, into bracket, observed minus expected, close the bracket, all squared, all over expected. Okay, so you are going to sum up all the chi-square you've computed for all the categories. So 3.3 plus 3.3 plus 3.3 plus 3.3. 3.33 plus 3.33 plus 3.33 plus 3.33. So calculated chi-square, here is it. Calculated chi-square is equal to 3.33 plus 3.33 plus 3.33 plus 3.33. That will give us 13.32. Okay, good. So the step 4 is you compute the chi-square statistic. So remember, in the step 4, you are going to redraw the table in another format. Now, remember, how do you know the format? This 2x2 table actually shows 4 formats, provided you understand the table. What are the formats? See, it shows 4 categories. Category 1, smokers with lung disease, they are 40. That's for the observed frequency table. So smokers with lung disease, 40. That's category 1. Category 2, smokers with no lung disease, the frequency is 20. Non-smokers with lung disease, the frequency is 20. Non-smokers with no lung disease, the frequency is 40. So you see, you are going to draw the 4 categories, write the 4 categories: smokers with lung disease, smokers with no lung disease. So this time you are going to write it straight. So instead of writing it like a 2x2 table, this time you are going to draw the table in a different format and write it straight. The reason is because we want to draw a table where we will see both the expected and the observed in the same table. So you see, you write it: smokers with lung disease, observed is 40. Smokers with no lung, here is it. Someone will say, where did we get the 40? Here is it. Smokers with lung disease, 40. Smokers with no lung disease, 20. So here is it. So you see, smokers with lung disease, 40. Smokers with no lung disease, 20. Non-smokers with lung disease, 20. Non-smokers with no lung disease, 40. So you see, here is it. Smokers with lung disease, 40. Smokers with no lung disease, 20. Non-smokers with lung disease, 20. Non-smokers with no lung disease, 40. When you come to the expected to the same, okay, smokers with lung disease, 30. Here is it. Smokers with lung disease, expected 30. So you see, smokers with no lung disease, expected 30. So you see, here is it. Smokers with no lung disease, expected 30. Non-smokers with lung disease, observed 20. Here is it. Non-smokers with lung disease, observed 20. Non-smokers with lung disease, observed 30. Here is it. So you see, non-smokers with lung disease, observed 20, expected 30. So you see, non-smokers with lung disease, expected is 30. So this is the expected frequency table. So in the step 4, you are going to draw another table showing all the 4 categories and also showing for the observed frequency and expected frequency. And this is how you draw the table. After the table, create another column and interpolate the frequencies into the formula. And this is the formula we use to compute the chi-square test statistic. There's the formula. Okay, there's the formula we use to solve the calculated chi-square statistics. S squared, capital S squared is equal to summation of into brackets observed minus expected, close the bracket, all squared, all over expected. Capital S squared, this capital S squared, we call it calculated chi-square. So calculated chi-square is equal to summation of into brackets observed minus expected, close the bracket, all squared, all over expected. Okay, so you interpolate this into the formula. When you interpolate it into the formula, you do that for all the categories. So for smokers with lung disease, the observed is 40, expected is 40. You interpolate it into the formula. So you see 40 minus 30. So this 40 is for the observed. This 30 is for the expected. So 40 minus 30, close the brackets, all squared, all over 30. That will give us 100 over 30. That is 3.33. And you see, the column that you create, you have to write the formula there. Observed minus expected, close the bracket, all squared, divided by expected. You have to write. Okay, so you create another table showing all the 4 categories from the table. On that table, you show the frequencies for the observed table. This is the frequency for the observed table. And then this is the frequency for the expected table. You use it to draw this table, showing the observed frequencies and the expected frequency. Then you interpolate each category frequencies into the formula individually. So for this category, smokers with no lung disease, observed is 20, expected is 30. Here is it. Smokers with no lung disease, observed is 20. Here is it. Smokers with no lung disease, observed is 20. Come to the expected. Smokers with no lung disease, expected is 30. And that is what has been done over here. Smokers with no lung disease, observed is 20, expected is 30. You interpolate it into the formula. So observed is 20. So 20 minus expected is what? 30. 20 minus 30, close the bracket, all squared, all over expected is 30, all over expected. And that will give us 100 over 30. That is 3.33. You do that for all the categories. For all the categories, you interpolate it into the formula individually. So at the end, you get the calculated chi-square for each category. So you get 3.3 for the first category, 3.33, second category, 3.33, third category, 3.33, the last category. Then you sum all. So the calculated chi-square is equal to 3.33 plus 3.33 plus 3.33 plus 3.33. Overall, we will get 13.33. So this calculated chi-square is 13.33. Now, the step 5, you determine what we call degrees of freedom. You determine degrees of freedom. Now, what is the formula? Now, you remember that in confidence interval, when we were learning confidence interval calculation, we have a different formula for calculating degree of freedom, the n-1. Now, in chi-square testing, when you have a 2x2 table or any kind of table at all that you are given, the degree of freedom, the formula is different. The degree of freedom, the formula is given by df is equal to, into bracket, r minus 1, close the bracket, open the bracket, c minus 1. df is equal to, into bracket, r minus 1, close the bracket, open the bracket, c minus 1. So df, degree of freedom, is equal to, into bracket, r minus 1, close the bracket, open the bracket, c minus 1. Now df is equal to, now how do you, what is this r? R represents the row total, or the number of rows. Sorry, the number of rows. And then c represents the number of columns. Okay, now in a 2x2 table, like this table is a 2x2 table. How many rows do we have? This is the row 1, 2 rows. How many columns do you have? 1, 2 columns. Remember, this is not part of the columns. This is not part of the columns. The columns are for just the frequency. So we have 1, first column, second column. What is the row? First row, second row. So we have 2 rows and 2 columns. Let's go over it again. How many rows? These are the rows. Don't count this as part of the rows. Don't count the totals 2 as part of the rows. Don't count this as part of the columns. And don't count this as part of the columns. Now, these are the columns. Column 1, column 2. So we have 2 columns. These are the rows. Row 1, row 2. So we have 2 rows. That's why it's a 2x2 table. So 2 rows and 2 columns. So it means that the df is equal to, into bracket, row is 2. So 2 minus 1, close the bracket, open the bracket. C, which is the column, is also 2. 2 minus 1. Now remember, anytime you are given a 2 by 2 table like this, DF will always be equal to 1. Anytime you are given a 2 by 2 table like this, remember a 2 by 2 table like this, DF will be equal to 1. Why? Because the rows are 1, the columns are 1. Remember, anytime you are given a 2 by 2 table like this, the row is 1, the column is 1. So automatically the DF will be equal to 1 when you put them into the formula. So DF will be equal to, into bracket, 2 minus 1, close the bracket, open the bracket, 2 minus 1, that will be equal to 1. DF is equal to, into bracket, R minus 1, close the bracket, open the bracket, C minus 1. DF is equal to, into bracket, 2 minus 1, close the bracket, open the bracket, 2 minus 1, close the bracket, all is equal to 1. Remember, anytime you are given a 2 by 2 table like this, DF would automatically be equal to 1. Now, step 6, find the critical value. That's step 6. You find the critical value. Step 6, you find the critical value. How do you calculate for the critical value? You use the DF and then the alpha level. Now, remember, we stated the alpha level in step 2. The alpha level is equal to 0.05. The alpha level is already in the question. That is 5% significance level. Okay, so the significant level is 5%. If significant level is 5%, it means alpha level is 0.05. So that is what you are going to use in the step 6. The step 6 says that find the critical value. Find the critical value. Find the critical value. Now, how do you find the critical value? You use the DF, which is equal to 1. We had that from the step 5. And then the alpha level that you had in the step 2. Now, once you have the DF is 1, the alpha level is 0.05. Come to the chi-square distribution table. We have a distribution table we call the chi-square distribution table. Come and check for the DF1. So DF is 1. And check for level of significance, 0.05. So the level of significance, so look, DF is 1. Level of significance is 0.05. Come to the chi-square distribution table and look for DF1. And then look for level of significance, 0.05. So DF is 1. Level of significance is 0.05. So you see, the critical value is 3.841. So the step 6, we are going to find the critical value. How do you find the critical value? You use the DF and then the alpha. Now, what is the alpha? 0.05. What is DF1? So trace the DF1 against alpha, 0.05. You realize that the critical value is this. So alpha is 0.05. DF is 1. So you see, the critical value is 3.841 or 3.84. Now, after getting the critical value, now what we are going to do now is that we are going to compare the chi-square that we calculated, the calculated chi-square, with the critical value. That is what we are going to do. But before you do that, step 7, you make a decision or you state your decision rules. Decision rules, or you state your decision rules. Now, there are 2 decision rules when you are doing chi-square calculation. There are 2 decision rules. We have 2 decision rules. Now, the first decision rule is that if the calculated chi-square, this is what we call the calculated chi-square, this. The step 4 is what gave us the calculated chi-square. This final answer we have here is what we call the calculated chi-square. Now, in the decision rule, the first decision rule states that if the calculated chi-square is greater than the critical value, if the calculated chi-square, this is the critical value. If this calculated chi-square is greater than this critical value, this is the conclusion. You reject the null hypothesis. That is the first decision rule. Now, the second decision rule, if the calculated chi-square is less than or equal to the critical value, you fail to reject the null hypothesis. So let's go over it again. Now, the first decision rule. The first decision rule says that if the calculated chi-square is greater than the critical value, you reject the null hypothesis. If the calculated chi-square is greater than the critical value, you reject the null hypothesis. The second decision rule, if the calculated or the computed chi-square is less than or equal to the critical value, you fail to reject the null hypothesis. So now see, from our question, from the calculation, see, you see the calculated chi-square is 13.32. And then the critical value is 3.84. Come and compare it to the decision rule. So you see, if the calculated chi-square is greater than the critical value. Now, see, our calculated chi-square is 13.32. The critical value is 3.84 and is greater. So it means that it fulfills the first decision rule. The first decision rule says that reject the null hypothesis. Now, when you reject the null hypothesis, do you know what that means? Ask yourself, what is the null hypothesis? The null hypothesis states that there is no relationship between smoking status and lung disease. Now, when your calculation fulfills the first decision rule, what it means is that reject the null hypothesis. The moment you reject the null hypothesis, it means you've accepted the alternative hypothesis. But in statistics, when you say you've accepted the alternative hypothesis too, it's wrong. So the best thing to say is that we reject the null hypothesis. When you say you've rejected the null hypothesis, it's just the same as saying you've accepted the alternative hypothesis. But in statistics, we don't want you to say that you've accepted the alternative hypothesis. Instead of saying you've accepted the alternative hypothesis, say you've rejected the null hypothesis. Do you get it? If you say you've rejected the null hypothesis, it's just the same as saying you've accepted the alternative hypothesis. But in statistics, we do not want you to make that statement that you've accepted the alternative hypothesis. We want you to say that you've rejected the null hypothesis. Okay, so the decision rule says that if the calculated chi-square is greater than the critical value, reject the null hypothesis. So that means that we fulfill, this calculation fulfills that. So see, the calculated chi-square is 13.32. The critical value is 3.84, meaning we will have to reject. So you write, therefore, 13.32 is greater than 3.84. Therefore, we reject the null hypothesis. Now, the moment you reject the null hypothesis, step 8 is conclusion. Step 8 is where you state your conclusion. Now, what does this mean? You are going to explain what this means. So see, our calculated chi-square is 13.32. Our critical value is 3.84. So we are going to what? Reject the null hypothesis from the decision rule. Okay, the decision rule says that if the calculated chi-square is greater than the critical value, reject the null hypothesis. So you write, since 13.32 is greater than 3.84, we reject the null hypothesis. Once you reject the null hypothesis, what it means is that you go to step 8. Step 8 is the conclusion. Since the calculated chi-square value is greater than the critical value, we reject the null hypothesis. Now, you rejecting the null hypothesis means that you agree with the alternative hypothesis. But in statistics, we do not say, I accept the alternative hypothesis. Instead of saying, we accept the alternative hypothesis, all you say is that you reject the null hypothesis. And once you reject the null hypothesis, it means, in actual sense, it means you've accepted the alternative hypothesis. And that means that there is actually a relationship. What is the alternative hypothesis? The alternative hypothesis states that there is a relationship between smoking status and lung disease among adults in the community. Okay, good. So the moment you do your calculation and the calculated chi-square, this calculated chi-square is greater than the critical value, what that means is that this data, from these observed frequencies, there is enough evidence for you to say that there is a significant relationship between the two variables in the question. That is the meaning. Okay, so hypothesis testing basically goes through 8 steps. 8 steps. It goes through how many steps? 8 steps. Now let's go over the steps again for the second time. Now the question says that a health worker wants to know whether there is a relationship between smoking status and the presence of lung disease among adults in a community. Now, the data collected are shown below. Now, we have smokers with lung disease 40, smokers with no lung disease 20, non-smokers with lung disease 20, non-smokers with no lung disease 20. Now, for the total number of smokers, you add 40 plus 20, that is 60. From the total number of non-smokers, 20 plus 40, that is what? 60. For the total number of people with lung diseases, 40 plus 20, that is 60. For the total number of people with no lung diseases, 20 plus 40, that is 60. The grand total is 60 plus 60, 120, or 60 plus 60, 120. Now, the question goes ahead to say, test at 5% level of significance whether smoking status is related to lung disease. Remember, you can have a question that they will tell you to test at 2% level of significance, or test at, they can even say test at 95% confidence interval. That is the same as test at 5% level of significance. Okay, so the analysis, remember, the first step in hypothesis testing is you state your hypothesis. You state your two hypotheses. How many hypotheses do you state? Two hypotheses. The first hypothesis is the null hypothesis. The second hypothesis is the alternative hypothesis. Now, in stating your hypothesis, go back to the question and go and look at the variables you have in the question. A health worker wants to know whether there is a relationship between smoking status and the presence of lung disease among adults in a community. A health worker wants to know whether there is a relationship between smoking status and the presence of lung disease among adults in a community. Okay, good. So you go back. So the variables in the question, we have smoking status and lung disease. So you come and use that to state your hypothesis. Now, the first hypothesis, this is how you are going to state it. The null hypothesis, or H0, you are just going to write, there is no relationship between smoking status and lung disease. So see, the underlying word is no relationship. No relationship. No relationship. If you write null hypothesis, we don't see this. It's wrong. There is no relationship between smoking status and lung disease. Then the alternative hypothesis, there is a relationship. See, there is a relationship between. There is a relationship between. The moment you see any statement like this, there is a relationship between, it's an alternative hypothesis. The moment you see a statement like there is no relationship between, it's a null hypothesis. Anytime you see this no, the statement is representing null hypothesis. Anytime you see there is a relationship, the statement is representing alternative hypothesis. Now, the next step is step 2, choose the level of significance. Step 2, choose the level of significance. The level of significance would always be in the question. Now, from the question, the level of significance is 5%. 5% is the same as 0.05. 5% is the same as 5 over 100, and that's the same as 0.05. So the level of significance, alpha, is equal to 0.05. Alpha is the same as level of significance. So the level of significance, alpha, is the same as 0.05. Step 3, calculate the expected frequencies. Calculate the expected frequencies. Now, what formula do we use to calculate expected frequencies? What formula do we use to calculate expected frequencies? Expected frequency formula is equal to row total multiplied by column total all over grand total. Row total multiplied by column total all over the grand total. Row total multiplied by column total all over the grand total. Now, in the step 3, you have to draw another table. That table, we call it expected frequency table. Now, remember, the table that has been given you in the question, we call it observed frequency table. Now, you draw another table in step 3. We call it the expected frequency table. Now, in the expected frequency table, it's going to be the same table as this, just that you won't show the totals. Okay, the same table as this one. So a table having the smokers, non-smokers, lung disease, no lung disease. Just that this time you show the total, the row total, and then the column totals. Okay, so you draw another table. We call it the expected frequency. And you are going to use this formula to draw that table and have the frequencies. And I will show you how to do that. So you draw another table, smokers, non-smokers, lung disease, no lung disease. Now, how do we calculate the expected frequency? So you see, you are going to calculate the expected frequency for this 40, expected frequency for this 20, expected frequency for this 20, and expected frequency for this 40. Now, if you want to know the expected frequency for this 40, the formula says that row total, what is the row total? 60. And column total, what is the column total? 60. So 60 row total 60 multiplied by the column total 60 divided by grand total 120. And that is what has been done over here. 60 multiplied by 60 divided by 120, that is 30. You do the same for all. So if you want to do for this, expected frequency for this is the row total for this 20 is 60. Column total for this 20 is 60. 60 multiplied by 60 divided by 120. So 60 multiplied by 60 divided by 120. That will give us 30. Okay. Then you come and do same for this one too. The 20. What is the row total? 60. What is the column total? 60. 60 multiplied by this 60 divided by the grand total 120. You do same for this 40. What is the row total? 60. What is the column total? 60. Formula says row total multiplied by column total divided by grand total. And that is what has been done over here to get another table over here. So the expected frequencies, you get 30, 30, 30, 30. Okay, 30, 30, 30, 30. Now the question is, why are we calculating or doing another table to show the expected frequency? Or what does the expected frequency means? Now the expected frequency is basically showing us how the observed frequency will actually look like, the data will actually look like if indeed there was actually no relationship between the variables. If truly there was no relationship between the variables, how would the frequencies look like? Or in other words, if indeed the null hypothesis was actually true, how would the table look like, the frequencies look like? That is what the expected frequency is showing. And that's the reason why most of the time, the expected frequencies are going to be similar in most situations. They can have situations where the expected frequencies will differ. Is that okay? Great. Now, the step 4, you compute your chi-square test statistic. The step 4, there is a formula for doing that. The calculator, this one, we call it, you calculate the chi-square test. Now, the calculated chi-square, you represent it by S squared. Now, the calculated chi-square is equal to summation of into bracket observed minus expected, close the bracket, all squared, all over expected. Calculated chi-square is equal to summation of into bracket observed minus expected, close the bracket, all squared, all over expected. Summation of into bracket observed minus expected, close the bracket, all squared, all over expected. Summation of into bracket observed minus expected, close the bracket, all squared, all over expected. Now, in the step 4, you have to draw another table using these tables, these two tables. You are going to use these two tables, the observed frequency table and then the expected frequency table, to draw another table. You draw another table showing the observed frequency table and then the expected frequency table. You draw another table showing the observed frequency table and the expected frequency table. Now, let's go back to the table. This is the table. So look at the table. Now, from this table, we actually have 4 categories from this table. From this table, we have 4 categories. What are the 4 categories? We have smokers with lung disease, category 1. Smokers with no lung disease, category 2. Non-smokers with lung disease, category 1. Non-smokers with no lung disease, category 4. So we have 4 categories. Smokers with lung disease, category 1. Smokers with no lung disease, category 2. Non-smokers with lung disease, category 3. Non-smokers with no lung disease, category 4. So you are going to write all the 4 categories here. That's the first thing you do. Okay, so here is it. Smokers with lung disease, category 1. Smokers with no lung disease, category 2. Non-smokers with lung disease, category 1. Category 3. Non-smokers with no lung disease, category 4. And that is what has been written over here. Smokers with lung disease, category 1. Smokers, no lung disease, category 2. Non-smokers, lung disease, category 1. Category 3. Non-smokers, no lung disease, category 4. If you like, you can number it 1, 2, 3, 4 to show all the 4 categories. If that wouldn't confuse you. That is fine. Okay, so you would draw another table showing all the 4 categories. Then you write the observed frequencies for the, so you write all the observed frequencies. On that table, you have to show the observed frequencies and also show the expected frequencies. This table is showing the observed frequencies. So smokers with lung disease, 40. Smokers with no lung disease, 20. So here is it. So you see for the observed table, frequency, smokers with lung disease, 40. Smokers with no lung disease, 20. And that is what is shown over here. So you see smokers with lung disease, 40. Smokers with no lung disease, 20. Non-smokers with lung disease, 20. Non-smokers with no lung disease, 40. And that is what we have over here. Okay, so smokers with lung disease, 40. Okay, smokers with no lung disease, 20. Non-smokers with lung disease, 20. Non-smokers with no lung disease, 40. That is what is over here. So this table is showing the observed frequency. So smokers with lung disease, 40. Smokers with no lung disease, 20. Non-smokers with lung disease, 20. Non-smokers with no lung disease, 40. You do the same thing for the expected frequencies too. So you see, the table is going to show the 4 categories and show the observed frequencies from this table, and then the expected frequency from this table. That is what. So we use the 2 tables to draw the table in the step 4. So we use the observed frequency table in the question, and then the expected frequency table that you calculated in step 3 to draw the table in the 4th step. On that table, you have to have the observed frequencies, the expected frequencies, and then a formula that would show how you interpolated the frequencies into the formula. So we have now the formula for calculated chi-square is equal to summation of observed minus expected, close the bracket, all squared, all over expected. Now, you interpolate the frequencies at the various categories individually or separately into the formula. So you take the first category, smokers with lung disease, observed is 40, expected is 30. Here is it. Smokers with lung disease, observed is 40. You come to this table, smokers with lung disease, expected is 30. So here is it. Here is it. Smokers with lung disease, observed is 40, expected is 30. You interpolate it into the formula. The formula says that observed minus expected, close the bracket, all squared, all over 30. That will give us 100 over 30. The 30 here is the E, which is the expected. So 40 minus 30, close the bracket, all squared, all over the 30. So 40 minus 30, close the bracket, all squared, all over 30. Okay, you do same. So you interpolate all the frequencies into the formula separately, and in the end, you are going to get here, you are going to get 3.33, here 3.33, here 3.33, here 3.33. Then now the formula says summation, so you sum. So S squared is equal to 3.33 plus 3.33 plus 3.33 plus 3.33. That will give us 13.32. Step 5, you determine the degree of freedom. How do you determine the degree of freedom? In chi-square test statistics, degree of freedom is equal to, into brackets, R minus 1, close the bracket, open the bracket, C minus 1. This R represents the number of rows in the question or in the table, and this C represents the number of columns. Come back to the table. Look at this table. Okay, so the table C, don't count this as part of the rows. Sorry, don't count this as part of the columns. And don't count this as part of the rows. Don't count the totals. And don't count where we have the categories as part. Don't count where we have this. We use the frequency. So you see we have row 1, row 2, column 1, column 2. Okay. You can, I think the expected frequency table even make it simple for you. This is not part of the rows. This is not part of the columns. So here we have row 1 and row 2, column 1 and column 2. What it means is that we have 2 rows and 2 columns. So that means DF is equal to row is 2, 2 minus 1, close the bracket, into bracket. The column is also 2, 2 minus 1. Now remember, anytime you have a table like this, anytime you have a table like this in chi-square test, a table like this, automatically the DF is equal to 1. Anytime you have a table like this with 2 rows and 2 columns, automatically the degree of freedom is equal to 1. Now, step 6, find the critical value. Step 6, find the critical value. How do you find the critical value? You use the degree of freedom and the alpha level. What is the degree of freedom? The degree of freedom is equal to 1. The alpha level from step 2. Step 2 is where we look for the alpha level. It will always be given in the question. It's 5%. Okay, so you use the degree of freedom and the alpha level. Now, once you know the degree of freedom 1, the alpha level 0.05, go to the chi-square distribution table. Now, from the chi-square distribution table, trace DF1 and trace level of significance 0.05. So DF is 1, level of significance is 0.05. So the critical value is 3.84 here, 3.841. Critical value is 3.841. Now, so that's why we have critical value. So S squared critical. This one is S squared calculated. This is the S squared calculated. That is 13.32. And this is called S squared critical value. That is 3.84. Now, step 7 is called decision rule. You are going to state the decision rules. We have 2 automatic decision rules in chi-square test. 2 decision rules in chi-square test. The first decision rule is, if your calculated chi-square is greater than the critical value, reject the null hypothesis. Now, this decision rule, what it simply means is that if your calculated, if this one is greater than the critical value here, reject the null hypothesis. What that means is that if your calculated chi-square is greater than the critical value, then it means that you have to accept the alternative hypothesis. But in statistics, when you make a statement, accept alternative hypothesis, is wrong. So in statistics, instead of saying we accept the alternative hypothesis, we rather want you to say we reject the null hypothesis. When you tell us we have two hypotheses. So if you tell us you've rejected the first one, it's like automatically you've accepted the second one. That's the meaning. Okay, but in statistics, we don't want you to make that statement. We accept the alternative hypothesis. We say we reject. So from our question, once our calculated chi-square is greater than this critical value 3.84, we reject the null hypothesis. That means that what that means is that there is actually a relationship between smoking status and lung disease. That's the meaning. So in the step 7, state the 2 decision rules. The first decision rule, if the calculated chi-square is greater than the critical value, reject the null hypothesis. Decision rule 2, if the calculated chi-square is less than or equal to the critical value, you fail to reject the null hypothesis. So you see over here, you fail to reject the null hypothesis. In statistics too, you can't say you accept the null hypothesis. You fail to reject. Okay? You fail to reject the null hypothesis. The moment you make a statement like you fail to reject the null hypothesis, that means automatically you've accepted the null hypothesis. So the decision is always on the null hypothesis. In statistics, in hypothesis testing, the decision is always on the null hypothesis. The decision is always on the null hypothesis. Okay, good. So in our calculation, the calculated chi-square is 13.32. The critical value is 3.84. So it means that our calculated chi-square is greater than the 3.8. So we fulfill the first decision rule. We reject the null hypothesis. Therefore, since 13.32 is greater than 3.84, we reject the null hypothesis. Now, step 8 is conclusion. Now, since our calculated chi-square of 13.32 is greater than the critical value of 3.84, we reject the null hypothesis. Therefore, there is a significant relationship. Once you reject the null hypothesis, that means that there is a significant relationship between the 2 variables. It means you've accepted the alternative hypothesis. And the alternative hypothesis states that there is a relationship between smoking status and lung disease. Okay, this brings us to the first part of hypothesis testing, chi-square test statistics. I'll come your way with 2 more videos, part 1 and 2, to walk you through more examples on chi-square testing. Thank you so much for following through to the end. Bye-bye.